Welcome to all of you. In this session, we are going to have one more microcontroller program, that is exchange of the data. Let us go through the question statement. Write an ALP to exchange the source block starting with the address 20H internal RAM containing n, that is 5 bytes of data with the destination block starting with the address 50H, that is internal RAM. So in the program we are going to make use of these three registers, and let us first understand the purpose of these registers. R0 is used as a source memory pointer, R1 is used as destination memory pointer, and R2 is used for count value. Now here is the program for that. So R0 will be pointing to the source memory location, R1 will be pointing to the destination memory location, and R2 will be holding the count value, that is how many values we need to make the exchange. So that will be available in the R2. And in order to make the data to be stored temporarily, we are going to make use of the two registers, that is accumulator A as well as one more register B. Now let us get into the program. So move R0 comma hash 20H, the source memory value will be stored into the R0. Move R1 comma hash 50H, the destination memory location value will be stored to the R1. Then how many values we need to make the movement? So that will be in the R2, that is move R2 comma hash 05H. Then move A comma at R0. So the value stored in the memory location pointed by the R0, that is nothing but the memory location 20H, is now moved to the accumulator. We are performing the exchange operation from source to destination and the value from destination to the source. So we need a temporary registers to store the value of the current location. Therefore, we are using A and B. So for the source, we will be using the A, and for the destination value, we are using the B. Now, the value in the source pointed by R0 is moved to the A, and then the value pointed by the R1, that is the destination, is moved to the B. Now, these two values are now temporarily available in the A and B registers. So now we can overwrite the contents of the source as well as the destination in the current location. Now the destination value that was stored in the B is now being moved to the source location. The value at the source which we had temporarily stored in A is now being moved to the destination. Then after, increment R0, increment R1, increment the source as well as the destination memory location, then decrement jump on no 0 R2 comma loop. Decrement the R2, verify is it equal to 0. If it is 0, come out of the execution, otherwise move back to the loop and repeat the same process again. Now let us observe the same thing in the simulation. Let us first consider the data available in the source as well as the destination. So that means before execution. So this is the source starting from 20H to 24H, total 5 data. So the data available are sequentially 10, 20, 30, 40 and 50. Like that, the destination starts from 50H, and in that the data available will be 0A, B, C, D and EH sequentially. Now let us get into the iteration process. Now this is the program that has been explained, and what happens in each iteration. Now that is being shown over here. Total 5 data are being exchanged. Therefore, there are 5 columns over here that each column indicates one iteration. Starting with the first iteration. So move R0 comma hash 20H. So R0 will be loaded with the 20H value. Then move R1 comma hash 50H. R1 is loaded with 50H. Move R2 comma hash 05H. R2 will be loaded with 05H. Then move A comma at R0. Now the value present in the memory location pointed by the R0 will be moved to the A, and that is what the memory location 20H. So in that memory location the value available is 10H. Therefore accumulator is loaded with the value 10H. Similarly move B comma at R1. So B will be loaded with the value 0AH. That is 0A is the content available in the memory pointed by R1. Now make the exchange of the data to the location R0 at R0. Move the contents of B, that is at memory location 20, 0A will be stored. Similarly to the location 50H, 10H will be stored. So the data has got exchanged. Now increment the memory locations. So increment R0, R0 will become 21H. Then increment R1, R1 will become 51H. Then decrement R2, jump on no 0 back to the loop. So R2 is decremented by 1. Now it is equal to 4. It is not equal to 0 until it becomes equal to 0. It will be in the loop. The one which is shown in the color, that is the looping part, and one which is shown in the black color, that is one time execution. Now let us go through the second iteration. So in the second iteration, now the move A comma at R0, A will be now loaded with the value 20H. Next B will be loaded with the value 0BH. Then move at R0 comma B at the location 21H memory location 0B will be stored. Similarly at memory location 51H 20H will be stored. So exchange of data has happened. Now increment R0, that will become 22. Increment R1, that will become 52. Decrement the R2 and check if it is equal to 0 or not. It has got decremented. Now the value is 3, which is not equal to 0. So again go back to the loop for further execution. Now these are the remaining iteration, as you can make the observation. So in the next iteration similar process is going to happen, and at the last iteration R2 become equal to 0. That indicates all 5 data has got exchanged and the execution will exit from the loop. Now after the execution and before execution, what will be the status? We can have an observation. So this is before execution, these two. So this was the data available before execution, and after execution, as we can observe, the data has got exchanged. Let us start the execution of the program. So first build the program to find out for any errors. Then after start the debug process. So let us open the memory location. So memory. So first let us feed the data to the source as well as the destination memory location. So source memory location, we have taken it as 20H. So 20H is available here, and the destination memory location is taken as 50H. So 50H is here. Both are internal memory locations. Now let us put the data over here. So that is 10H, 20H, then 30H, 40H, then 50H, total 5 data. So now let us feed the data in the destination. So we'll have 0AH, then 0BH, then 0CH, then 0DH, and 0EH. So total 5 data. So as you can observe, the data are available in the source as well as the destination locations. And now let us start the execution. So I will use the function key F10 for stepwise execution. And as you can observe the changes in the registers. Now the R0 is loaded with the memory location 02H, that's the immediate data now. Then R1 is loaded with 50H, R2 is loaded with the value 5, and then observe in the accumulator. So accumulator A as well as the B has to get updated. So now first accumulator A, so that is the source data has got loaded. Now in the B, the destination, that is 0A, has got loaded. Now the contents has to get exchanged. Now make the observation in the memory locations. So in the source it has got updated. In the destination now it has got updated. So R0 has to get increment. So R0 21, R1 51. So R2 will get decremented by 1, that is 4. So it will move back to the loop. So this process will continue until all the datas are moved to the destination. The last iteration. So R2, if it is decremented, now it has become equal to 0. That means the program execution has to come to an end. So program execution has come to an end. Thanks for watching.